everyone, welcome to the inverse of a 2 by 2 matrix video. In this video, we'll finally get to do an inverse problem and see finally the significance of an inverse. And so basically, before I do the actual inverse of a matrix, think about a number such as 14. Okay, it doesn't matter. So if I have some number, what's the inverse of 14? Well, it's just a reciprocal of that, right? So inverse of 14 is 1 over 14. Okay, what's the significance of this? Well, if I multiply the number, right, I'm just going to say some number, and the inverse of that number. So inverse of that number, what do I get? Well, I always get 1, right? And unless, of course, the number is 0, then this product doesn't exist. But assuming that this product does exist, number times its inverse is equal to 1. Okay, and the reason why we can apply this, right? So let's say if I have some sort of an equation like 5x plus 10 is equal to, I don't know, just 5. Doesn't matter. So how do I solve this, right? So I subtract 10 from both sides and I'll get 5x is equal to negative 5, right? Now I need to figure out the inverse of the coefficient over here, right? That's the only way I can get the x all by itself. So what do? I take the 1 over the number in itself, so 5. And then I multiply it to both sides, and I'll get 1 over 5. On this side, the 5's go away, and I'll get x is equal to negative 1, right? So that's the significance of an inverse, and an inverse helps us solve for systems of equations. Now, if we have a system of equations with matrices, we don't know how to figure out how to get rid of matrices on both sides of the equation, or just one side of the equation, right? So that's why we need the inverse. So we'll start off by figuring out the inverse of a 2 by 2 matrix. And let's see, the way we go about doing that is, let's say I have some matrix A, and then I'll say the elements of A are A, B, C, and D. Okay? Then A inverse is 1 over the determinant of A, right, times the multiplied by, we take the A term and we take the D term and we flip them, we switch them up, okay? We switch them up. So now my first element, instead of being A, is D. My last element, the bottom right element, instead of being D, is now A. And then we take the negatives of the B and the C term. So I'll get negative B out here and negative C out here. Okay, so that's it. This is a formula for the inverse of a 2 by 2 matrix. Okay, inverse of a 3 by 3 matrix is you'll see it's a bit more complicated. Okay, but it's still not the worst thing in the world. And if you really want to know a shortcut method, it will help you figure out an inverse of an n by n matrix. It's called a method through row reduction, and I sometimes use it if I need to find the inverse of a 3 by 3, because I have a hard time remembering all these steps. But row reduction it's a completely different topic. I'll do like a couple of videos by itself for that, but don't worry too much about it for most of your exams, unless if you're in a linear algebra course, then you need to know row reduction. So okay, so this is a formula for the inverse of a matrix, and that's why we see that, okay, determinant is very important. I need to know what a determinant was in the first place. So let's say I have some matrix, and do an example. So in this example, let's say I have I'm gonna try a different color. My matrix is B is equal to 2, 1, 3, 8. Okay? So the first thing I need to do is, what's the determinant of this matrix? Well, that B is equal to the product of the diagonal, so 2 times 8, which is 16, minus 3 times 1, which is 13. Okay? Now, so I'm done with the 1 over the determinant of A part, almost, right? And now, I can just quickly do the A inverse. So A inverse would be 1 over the determinant, so 13, times flip the d and a and the d terms with one another. So 8 here and then the 2 here, and then take the negatives of the b and the c term. So 1 and 3 will be -1 and -3. Alright, if I want to, this isn't really mandatory, but depending on your instructor or the problem on the exam, you don't need to do this, but let's say you had to, you can just multiply out this constant with each of the elements. So now a inverse is equal to 8 over 13 times -1 over 13 times -3 over 13, and then 1 over 13 times 2 is just 2 over 13. Okay? Now, let's see. I'm just going to do it on the next slide. Let's say I have b is equal to 0, 8, 14, 0. Okay? How do I find the inverse of this matrix? So what is b inverse? B inverse will be 1 over the determinant of b, and then multiplied by the zeros and switch out, but they're the same number, so it's 0 and 0. Take the negative of the 8 and the negative of the 14. So what's the determinant of b? Well, the determinant of b is equal to 0 times 0, which is 0, minus 14 times 8. So I don't know what 14 times 8 is. I'm sorry. I always have to multiply it out. So 8 times 4 is 32. I used to know it back in 5th grade when we learned the multiplication tables. So that's 8, 9, 10, 11. So 112. Okay? So in this case, my determinant is negative 112. Okay? And so my b inverse is equal to just -1 over 112, 0 minus 8 minus 14, and 0. Okay, now let's do another example. This will be the last one. Let's say I have 2, 2, 3, 3. I don't know, something like this. What's the determinant now? Well, determinant of this matrix G, whatever. Determinant of G is 2 times 3, right? So that's 6, minus 2 times 3, which is 6. So 0. No problem, right? Well, not quite. So what's the formula for the inverse of a 2 by 2? G inverse is equal to 1 over the determinant of G. And then to that, we'll have this flippity flip, right? So 3, 2, and -2, -3. But can we even progress from this? No. Well, why? Because 1 over determinant of G will be 1 over 0, and 1 over 0 is undefined. So undefined times any matrix, well, undefined times anything will simply be undefined, so it does not exist. So that is why we need to have a determinant be some value other than 0 for the inverse to even exist. Okay, one quick way you can figure out if you found the inverse, if your inverse is correct, is let's say you have some matrix A, and then you have A inverse. If you multiply A and A inverse with one another, you should get the identity matrix. If you did it correctly. If you did it correctly, you'll always get the identity matrix. Okay, so let's say both of these matrices are 2 by 2, so the inverse will also be a 2 by 2, then your result should be 1, 0, 0, 1. And remember how I said in the identity matrix video that the identity matrix acts like a 1 in the matrix world. And this makes sense, right? Because if I have some number, like we showed in the last slide, some number, and that number's inverse, we should always get 1, unless that number is 0. And that's the same thing. The same thing holds true for the matrix world as well. Some matrix B multiplied by its inverse B inverse must give me an identity matrix, right? Identity matrix, n by n. Okay, so that's why we did this whole thing with dot products, matrix multiplication, how to figure out determinants, the property that the determinant must be other than 0, must be equal to be something other than 0 for it to be even invertible. And then we finally showed how to do the inverse of a matrix. So that's it for this video, and I'll see you in the next one.